Alright guys, we're doing problem 55 of chapter 6. This one involves inclines and it's talking about, let's just read the problem. A machine at a post office sends packages out a chute and down a ramp to be loaded into delivery vehicles. A. Calculate the acceleration of a box heading down at a 10 degrees slope, assuming the coefficient of friction for a parcel of unwaxed wood is 0.1. So that's part A. So let's just write down everything we know. We know that there's no mass. So that might lead to some cancelizations, some canceling in the formulas. We know the theta is 10 degrees. And then we know the friction coefficient is 0.1. So if we know that the downhill force, and another thing to look out for, if there's no mass involved, then we actually don't even want to deal with forces. It's just going to be with accelerations. So you can either just cancel out the mass when you have the forces, or you can just skip that part and just use the accelerations, which is what I'm going to do. So the acceleration for downhill would be sine theta times the gravitation acceleration. So this is the downhill acceleration. And then our acceleration caused by friction is, let's just say sub k or something. The coefficient times the cosine of theta times g. So let's just set up, let's find the total acceleration. Let's see. So since it's going to be moving downhill, we'll set this acceleration minus the friction. That way it's positive. So sine theta times g minus the coefficient of friction times cosine of theta times g. So let's go ahead and calculate this. And since we're moving downward, we're setting downward as the positive direction. G is also going to be positive, so just make sure you account for that in your calculation. So sine 10 times 9.81 minus 0.1 times cosine of 10 times 9.81. And we see that we indeed get the answer of 7.37 e negative 1. Or just 0.737, I guess. But this is the answer for part A. And I'll just do it with forces because that's usually what they're going to show. Like, that's what you're going to remember, right? Usually the downhill force would be sine theta mass times gravity. And then the friction force would be coefficient of friction times cosine theta times mass times g. It's the same thing, except you would actually need to know the mass. And it would give you the force. But the acceleration is always the same. So it's independent of the mass. So yeah. So in conclusion, if there's no mass in the problem, you would just use acceleration. You would just exclude the mass. Alright, so that's part A. Let's go ahead and do part B. Part B says, find the angle of the slope down which this box could move at a constant velocity. You can neglect air resistance in both parts. Okay, so again, we're just using accelerations here, so find the angle. So whenever it says find the angle with any problem, you're most likely going to have to take the inverse of some function, the inverse of some trigonometric function, right? So we know that if the velocity is constant, that means acceleration has to be 0, and the only two accelerations are your downhill acceleration and your friction acceleration. So let's just rewrite that. A sub k equals the coefficient of friction times cosine theta times g, and then our downhill force equals sine theta times g. So if these combined equal 0, that means there's no acceleration, and that means there's constant velocity. So let's go ahead and do that. Again, we'll treat the downhill force as positive. Doesn't really matter, but just makes sense because friction is always opposite of the direction you're going. So sine theta times g minus coefficient of friction cosine theta. And we're using kinetic friction here, coefficient of kinetic, because we assume it's moving based on the problem. Sending down ramp. But yeah, we only have one coefficient given to us, and we just use that. It doesn't really matter what the symbol is, I guess. So right, this equals 0, and that means we want to solve for theta here. So let's go ahead and these g's, we can take out a g and then divide both sides by g. So these g's just simply cancel out of the equation. And then we can move a sine theta over, so then it would be coefficient of friction times cosine theta equals negative sine theta. And then we can divide both sides by negative cosine theta, and then those negatives would cancel, so these negatives cancel. So then it would equal the coefficient of friction equals sine theta over cosine theta. And you can see that that's going to be indeed tangent of theta. So that's interesting. This coefficient equals the tangent of theta. Interesting relationship. So we simply take the inverse of both sides to isolate theta. So the arctan, arctangent of this coefficient, and then equals theta. So that's what we put in our calculator. So the inverse tangent of 0.1 will give you the answer of, so part B equals 71 degrees. So yeah, that's your answer. Hopefully that makes sense. If you have any questions, make sure to drop a comment, anything like that. Yeah, thanks for watching. I'm going to go continue on with number 56 next video, and then just continue down the list. So yeah. So